Gauss Jordan method. So in the Gauss Jordan method, we have to make all elements 0 except the principal diagonal elements. Okay, so this is principal diagonal elements. Okay, except these three, we have to make all other elements as 0. This is the concept of Gauss Jordan. Now, let me start. Let me write the augmented matrix first. So, what is that? Let me write the coefficients 1, 1, 2, and then 1 minus 2, 1. Next, 1, 3 minus 1, and 9, 8, 3. Okay. So, first, let me make these two as zeros. So, how to make this as 0? Directly 1 minus 1 means R2 is R2 minus R1. Next, R3, you have to make this multiplied by 2. Therefore, R3 is R3 minus 2 R1. Now, let me write this. So, R2, 1 minus 1, 0. Minus 2 minus 1, minus 3. 3 minus 1, 2. 8 minus 9, minus 1. Now, R3. 2 minus 2, 2 minus 2. Okay, this one. 2 minus 2, 0. 1 minus 2, minus 1. So, this is minus 1. Okay. So, 1 minus 2. Minus 1 minus 2 means minus 3. And 3 minus 18. So, that will be minus 15. We have to make these two elements as 0. So, how can we make here? See, R1. We can add these two. 1 minus 1 becomes 0. Okay. So, what about this? We have to connect with this here. Because if we add R3 with R1, then this may become number. Okay. Non-zero number. So, here with this, so R3, R2 plus 3R3, that we can do. Okay, so R1 is R1 plus R3. Next, R3 has to be, okay, R2 minus 3R3. R2 minus 3R3. Okay, now, see, we have to write R1. So, R1 is R1 plus R3. 1 plus 0, that is 1. Next, 1, okay, minus 1, that is 0. Next, 1 minus 3, minus 2. Next, 9 minus 15. So, what it will be? Minus 6. Okay. Next, R2 as it is. 0 minus 3, 2 and minus 1. Next, R3. R2 minus 3R3. 0, 0. It will remain 0. Next, see here. R2 is minus 3. Okay. Minus 3 into R3, that is minus 1. So, minus 3 plus 3 becomes 0. Next, here, R2, 2 minus 3 into R3 minus 3. 2 plus 9, that becomes 11. Next, here is 15. So, R2 is minus 1 minus 3 into R3, that is minus 15. So, minus 1 minus into minus becomes plus. 15 3s are 45. Therefore, it is 44. So, this we got. Now, one more thing we can do. See here, 11 and 44. We can simplify this. How? By dividing R3 by 11. Okay. Now, let me do that. So 11 by 11, 1, 44 by 11, that is 4. Okay, so now which are the elements left? These two. Now we have to make these two as zeros. How can we do here? See, for R1, we have to go for R3 only. Okay, so here -2 plus 2 can become 0. Therefore, R1 has to be R1, okay, plus 2 R3. Do this first, okay. So 1, okay, R1, 1 plus 2 R3. So this is what? 1. Next, 0, 0, 0. See here, R1 minus 2 plus 2 R3, that is 2. Therefore, this is 0. Next, R1 minus 6 plus 2 into R3, 4. That is minus 6 plus 8. Therefore, it is 2. Next, 0 minus 3, 2 minus 1, 0, 1 and 4. Okay. Now, see, almost done. The only thing is this one now. So, how to make this 0 now? R2 is R2 minus 2 R3. R2 minus 2 R3. What it becomes here? See now, R2, that is 0. Okay, so this becomes 0. Now here, R2, that is minus 3. Okay, minus 2 into R3, 0. So that will be minus 3 only. Okay, so this is minus 3. Next, R2, 2 minus 2 into R3, 1. So 2 minus 2 is equal to 0. Next, R2 minus 1. Minus 2 into R3, 4. So that is minus 1 minus 8, minus 9. So this is minus 9. Now we have got all the elements 0 except principal diagonal elements. So now we get the answers directly here. X equal to 2. Next, y. Minus 3y equal to minus 9. Therefore, y equal to 9 by 3 and that is 3. Next, z is equal to 4. This is how we get the solution of the equations using the Gauss Jordan method.